Hey, my name's Sushant, Sharma. I'm from Australia. I'm 20. I've been working on this since I was like 18 or so. And this is this. It is this thing called ineon, which I've named ineon. It's essentially plastic, but I don't like calling it plastic because it's not plastic. But it's an alternative to plastic that is derived from organic source. A waste product of the selfish industry. Um, that would otherwise be incinerated or thrown into the landfill. Um, and you can make this material, which is akin to plastic, which I named ineon. That is as strong, if not stronger, than regular plastic. Can basically be utilized in the same way regular plastic is. But the kicker is one, it's organically sourced, it's biodegradable, and then completely in water, soil, basically anywhere where food or organic material will decompose. So will this. And the biggest thing is the fact that it's cheaper. We're using a waste product that costs nothing, and in reality, we'd be able to get raw material at a profit, like at a negative cost. Um, and yeah, the reason I started was I read this report in 2015. That's when I was in year 12 at the time, finishing high school. Um, by the United Nations Environmental Program, the UNEP, and it was called the Marine Litter Report. And essentially, the conclusion it came to was that biodegradable plastics they were worthless. They didn't do what everyone thinks they do. Something can be called biodegradable if it decomposes in a industrial composter, where you need super high humidity, super high temperatures, none of which are found in the environment. So if you were to throw a biodegradable plastic bottle into the ocean, it'll just be as if it was regular plastic. It will be there in sorry, in 1,000 years time. Um, and um, and yeah, I'm a chemist normally, and I knew cellulose is a polymer and they make plastic out of that, but it's garbage. It's not biodegradable. Why don't they try to make plastic out of the second most abundant biopolymer, which is found in the wings of butterflies, the shells of shrimp, the shells of exoskeletons of insects. It's called chitin. It's everywhere. Um, Anywhere there's a bony, hard structure in an insect or fungi kingdom, it'll be made out of chitin. But it's not used for much. So I started working, trying to figure out, how can I actually make this happen? And it took like a really long time to actually get here. Because it's just iteration after iteration. Things work, things don't work. There's like infinite variables. I don't know what, like, like a slight change of one variable can end up, interacting with uh, another component of the actual composition in a way that I didn't foresee or knew. I've actually discovered a lot of things like that, like glycerol, which is like an alcohol that's used to soften things. There's a certain percentage threshold where it actually, once the total composition of something is that percentage, it becomes, it loses flexibility. It becomes stiff and rigid, which is like weird. Okay, this was supposed to be like 1 minute. It's already four. So.